the next formal language is a relational calculus. So as I told you previously, we have two flavors in this one. One is a tuple relational calculus and the other one is a domain relational calculus. So here in a tuple relational calculus, so we will be having a tuple variable. So this tuple variable is our final output. So this output depends upon the formula that we are going to specify in the query. So in detail we will be discussing about the syntaxes and all, and the same way here also in domain relational calculus, so we will be having a domain variable which will be our output based on the formula which is evaluated to true. So here in calculus, so we have variables, constants, comparison operators, logical connectivities and quantifiers. So all these things, okay, all together, so we can form a queries in a tuple relational calculus as well as a domain relational calculus. So here this tuple relational calculus, variables range over tuples, and whereas in DRC they range over domain elements. So coming to this first one, that is a tuple relational calculus. So in tuple relational calculus, so see here, so this is the basic syntax which we are going to write in this tuple relational calculus. T such that P of T, as I told you, T is a tuple variable and P of T is a formula which evaluates T to a true. If this condition, if P of T is true, then that a record or tuple will be stored in the left side, that is T. So whatever the tuples are evaluated to true, so those results will be stored in the tuple variable called capital T. And here when I come into in detail, when we will be discussing about what is P of T, so what formulas we can include in this P of T. So formula is recursively defined, starting with the simple atomic formulas and building bigger and better formulas using the logical connectivities. So these are the formulas which we can include in P of T. That is, so R belongs to rel. Here R is a tuple variable, so which belongs to rel. So rel is nothing but a relation name or R dot A of S dot B. Here R and S are the relations. So here S is also a relation, it's not a tuple variable. And here A and B are the respective are the attributes of respective relations R and S. Here R dot A of constant. So you can have an attribute name here, an operator followed by a constant value. Here you can see in the both the sides we can have the attribute values. So this so all these three are the atomic formulas which can be included in P of T. And here OP stands for operators, less than, greater than, equal to. These operators can be used in the formula. Apart from this one, so we have few more notations here to include in the formula. Negation P, P and Q, P or Q, where P and Q are formulas. At the same time, we can also use quantifiers here. There exists and for all. So this so here we can use the quantifiers, and we can also write the formulas and all. So we will take one small example here. So how we are going to write in this calculus and tuple relational calculus. So here the first query: find all sailors with a rating above 7. Find all sailors with a rating above 7. See here, so S such that S belongs to sailors and S dot rating greater than 7. So here whatever the tuples are there in the sailors, so they will be copied to this capital S. And now here you will be having a list of records or a list of tuples, and each tuple, okay, we will be comparing with this. So now S dot rating, so here you will be having value, and this value will be compared with this constant value. If the condition is true, then the respective tuple in S will be copied into this tuple variable called capital S, which is the left side of the such that symbol. So like that, again I will take another rating value from the S, and I will compare with the constant value 7. So if the condition is false, then I am not going to copy any tuple from this S to this tuple variable S. So if that means here, so this is all P of T. So if the condition is true, then the tuple values will be copied into this tuple variable S. So now we go for another query. Find sailors rated greater than 7 who have reserved boat ID 103. So here we are going to refer for two tables. From two tables we need to retrieve the information. So rating information from sailors and the boat ID information from reserves table. So we will see how we are going to write this query. Now here what we are going to do here is, so we are going to apply we are going to filter here the records from both the tables, and we are going to join the tables here. See it. So you just take this part. First we will discuss about this part, and then we will go for the later one. So in the first part, what we are going to do here is, so we are going to filter the records in sailors based on the rating. If rating is greater than 7, only those records will be stored in the tuple variable. So here we have and. So we are taking so there is for some R belongs to reserves, R dot SID is equal to S dot SID. So here what we are going to do, we are going to perform join operation here. We are going to join this reserves dot SID with the sailors dot SID. After joining, then we are going to perform, not after joining. So and this end condition, and R dot BID is equal to 103. So here first you will filter all the records from the reserves table where BID is equal to 103. So after getting the intermediate results, so then you are going to perform this join operator. Now here we are having some intermediate output, and here we are having an intermediate output. Now these two are going to join based on these conditions. So getting my point here. So here we are filtering based on the rating greater than 7, and here in this table I am filtering based on BID is equal to 103. So here I will get intermediate results, and here I will get intermediate results. Now I want to get sailor's information, like sailor's name or some other thing. So for this, what I need to do, I need to join these two. If I join these two tables, that is sailors and reserves, then only I can get the final output. So like this we can take a number of examples in our test book. We have a lot of examples, so we can go through as an exercise. Now coming to is a domain relational calculus. In domain relational calculus, as I told you, So everything is almost the same with the tuple relational calculus. So there we deal with the tuples, and here we deal with the domain values and all. So when we compare with the TRC tuple relational calculus, so this is the capital T, and this is a P of T. So there T is nothing but a tuple variable, and here x1, x2 to xn are domain variables. So now here this P of T, if you evaluate this P of domain variables, then you are going to get the output here. So this is your desired output, and this is your formula. Okay, so everything is same. So here whatever the atomic formulas we are going to include, everything is same as your previous TRC. As I told you, everything is same. So here we can use, so in previously we have taken R belongs to R name. So here belongs to R name, x of y or x of constant value. Here op is nothing but operators, less than, greater than, equal to, all these things. So apart from that, so we have additionally another atomic formulas. You can see here. So we will directly move into the example. Find all sailors with a rating above 7. Find all sailors with a rating above 7. So in relational algebra, how we are going to write? Yes, such that S belongs to sailors and S dot rating greater than 7. So here how we are going to specify the domain names here. So here I stands for SID, is name, rating and age. So here, and this INTA belongs to sailors and T greater than. So here if I want only a specific, only sailor names if I want to retrieve, then I will put only N here. So if I want only sailor IDs, if I want to retrieve as my output, then I will put only I here. I such that INTA belongs to sailors and T greater than 7, that it is going to display only sailor IDs. So as my question here is, find all sailors with a rating above 7. That means whatever the information is there, whatever the column names are there in this sailors, so all the domain names or column names I need to specify here. So this is how you are going to write this example. So this is another example which we are taking. Find sailors rated greater than 7 who have reserved boat 103. See here. So INTA, I want all the sailor information here. The same thing I am representing here also. It belongs to sailors and T greater than 7. This is one part. So this retrieves all the sailors who has whose rating is greater than 7. So now here I want the same persons who have reserved 103. I want reserved 103. I require. So for this, what I am going to do? So here, so BR is nothing but boat ID in results table. Boat ID in results table equal to 103. This is the condition here which I am going to specify, and this is the join condition. So this IR indicates that SID in a results table, and this I is SID in a sailors table. So this is the join condition, and this is the boat ID condition. And now here so here this is results SID, results boat ID, and this is the D. So these are domain variables, and now here this variables belongs to results, and IR is equal to I and BR is equal to 103. So now here you are going to filter the records here, and you will get one intermediate results, and here also you are going to filter the records and you are going to get intermediate results. And with the help of this joint condition, these intermediate results and these intermediate results will be combined, and finally you are going to get an output, and our output will be INTAME, sailor's ID, sailor's name, rating and age. So this is how we can write the same queries. We can write in relational algebra, in tuple relational calculus, domain relational calculus, and the structured query language. Okay. So generally in university exams also they'll keep asking, they'll give queries and they'll ask you to write in various languages, and we need to write and we need to explain so how we are going to how we are going to frame a query, and how you are going. So here the output will be same in whatever the language you are going to write, the output should be same here. So this is another examples here. So here in this example, we are going to join 3 tables here: sailors, reserves, boats. Why? Because